Alright, so let's say we have a pair of parametric equations. X is t squared plus 2 and y is defined as 4t. And the parameter interval, okay, we'll get to eliminate the parameter in just a second. The parameter interval is for values of t greater than or equal to -4 and less than or equal to +4. Now you can use your calculator to generate a table of the x and y values that we get from this set of parametric equations on this parameter interval. You would go in and enter the equations in x and y. So if I can pull up my calculator. Alright, so I'm going to change my x and my y equation to t squared plus 2 and 4t. Alright, then go to the viewing window and let your t minimum be -4 and the t maximum be +4. And I'll tell you what, I don't need to be there right now. As long as I've got the equations entered in x1 and y1, then I can go to the table setup. If all I need is a list of x's and y's, I can go to the table setup, let the table minimum or the table start be -4, and if we're thinking about plugging in specific values for t, we'd probably do -4, -3, -2, and so on all the way to 4. So that would mean the increment needs to be 1. Now, if you go to the table, then you see your ordered pairs. The first ordered pair is 18, -16. The second ordered pair is 11, -12. And then you can scroll down this list until you see all of the ordered pairs that you need. Now, if I were to think about graphing these equations, we'd be thinking about plotting points. The first point would be 18, -16, so that's somewhere down here. And then we'd have 11, -12. Alright, so we're plotting the ordered pairs x and y. T determines, the value of t determines what x and y are, and so indirectly it determines where the point is, but it's not, t is not a value that you think about when you're plotting your points. So 6, -8, 3, -4, 2, 0, and I'm just estimating kind of where these are. And then 3, 4, 6, 8. I need to come down my table. 11, 12, and 18, 16. So the way those points show up, you would think about sketching the curve in that order, kind of connecting those points in the appropriate order. So the positive orientation is that, if we're going to describe this graph, the graph starts at the point 18, -16 and travels left and up until it reaches the point 2, 0, which is the vertex of the parabola, and then continues up and back to the right, stopping at the point 18, 16. So you can plot the points by hand once the calculator has given you the coordinates, or of course you can go to your window and let the set it up correctly and let the calculator plot the points for you and sketch the curve. Let's see, if we have an x minimum, I'm thinking about what points I've got here on my graph. If my x minimum is, say, -1 and the x maximum is 20, actually I could go with 0 to 20 and that would be fine. X scale of 1 is going to be fine. Our y minimum is -16, so I'm going to go a little bit smaller than that. Y maximum is +16, so I'm going to go a little bit larger than that. Y scale of 1. Now again, if I remember to set the calculator up to show you the ball and chain, here we go. It will be very, very obvious when that curve is sketched, the positive orientation. Now, The other thing that you may be asked to do with a pair of parametric equations is eliminate the parameter. The parameter is the variable t. So basically we're going to take this pair of equations and get rid of t. Look at your pair and decide which one of those two equations is going to be easiest to solve for t. And I think it's the y equation. So solving that equation for t, 1/4 of y is equal to t. And then now you can plug 1/4 y in the x equation in place of t. So x will equal 1/16 y squared plus 2, which is actually the correct form of the parabola with a vertex at 2, 0, that sort of is laid over and opening up to the right. There are some graphs, some basic shapes of graphs that you're just going to need to kind of understand how to write the parametric equations for. Circles are one of the most, I want to say obvious, and that's probably not the right word, but I see lots and lots of applications of why we might need parametric equations to describe circles or to create circles. You need to just know that the pair of equations is always going to be, of course, x and y, and it's going to involve sine and cosine. I think, and of course you can generate a circle a different way, but if I would like you to think radius times cosine of the central angle, or cosine of t, for the x equation, and radius and sine of t for the y equation. And that goes back to thinking about the unit circle from trigonometry. The x coordinates of points on the unit circle are defined by the cosine of the angle. The y coordinates are defined by the sine of the angle. So this is a circle centered at the origin with radius r. R, not 4. So if we wanted to write parametric equations for the circle that had a center point at 0, 0 and a radius of 5, then those equations would be x equals 5 cosine of t and y equals 5 sine of t. Now, what parameter interval makes sense with that? If you simply want to generate one rotation around the circle, think about the values of the angle, the central angle t, that would give you a complete rotation. 0 to 2 pi is going to make sense. Okay, also keep in mind that this is, if you've got this particular setup, this is going to graph the circle counterclockwise. So what could you change if you wanted the same circle, but you wanted a clockwise graph? Wow, handwriting is really bad today. If I'd slow down. Okay, and what I suggest is you just want to think about the angles. Instead of angles rotating in a positive direction, which is counterclockwise, think about the angles rotating in a negative direction, clockwise. So change the sign on the angle and let x be 5 times the cosine of negative t and y be 5 times the cosine of negative t. No, times the sine of negative t. All right, again, the circle is centered at the origin. What if you needed a center? Okay, so we wanted counterclockwise rotation, so we're going to stick with the negative angles. And instead of the center at 0, 0, what if we needed the center to be the point 3, negative 2? Well, if you think about the center at 0, 0, and we want to slide it over so the center is at 3, okay, that's going to be a horizontal move. And what we want to do is we want to add 3 units to all of our x values. So 5 times the cosine of negative t plus 3 is going to shift that circle over so that the center is going to have an x-coordinate of 3. Same idea with the y values. We want our circle to come down from a y value of 0, thinking about the center point, to a y value of negative 2. So we're going to take 5 times the sine of negative t and subtract 2. Now it's worth graphing these on your calculator real quick just to verify that these are going to generate the correct circle we're talking about. If you need to write equations for lines, you need to describe lines using parametric equations. Your linear or your parametric equations are going to need to be in this form. The x equation is going to be x sub 0 plus a times t. Your y equation is going to be y sub 0 plus b times t. Now, if I take that general form of these parametric equations and I solve my x equation for t, so I say x minus x sub 0 is equal to a times t, and then x minus x sub 0 all divided by a equals t. And then I take that expression and put it in the y equation in place of t. Whoops. That is a plus right there. There we go. X minus x0 over a. Then with just a little bit of work, I'm going to subtract y sub 0, move it over, and then b divided by a times x minus x sub 0. Now I hope that you easily recognize that as a line that has a slope of b over a and goes through the point x sub 0, y sub 0. So if you know the slope of your line and some point that the line goes through, the x and y coordinates for the point are going to be the constant values there in your parametric equations. And then the slope is going to tell you what the coefficients ought to be for the t part of each expression. The top is the coefficient of t that goes in the y equation. The bottom is going to be the coefficient of t that's going to go in the x equation. So you can go both ways with that. If you're given a point and a slope, you can write the equations. Also, if you're given a pair of equations, parametric equations, okay, you can describe that line. It's going to be the line that goes through the point 4, negative 2, and has slope 6 divided by negative 3. The slope is negative 2. Use your calculator, graph that pair of equations. Of course, if you're talking about the entire line, parameter interval would be negative infinity to infinity.